In this video, we're going to be talking about buffer inside of ArcGIS Pro. Left off from a previous video, having just clipped my towns inside of the watershed here. Looks nice, looks really good. But maybe I'm interested instead of in these towns and the streams inside of the watershed here. So I've got all of these streams. Well, most of them, we don't need to worry about why those are missing. And all these streams, line files, line shape files, correspond to water bodies in one way or another. So you can see that they are, in some cases, outlining reservoirs, swamps, little brooks here. However, lines in vector data formats, line shape files like these, are actually sizeless. There's not a better way to say it. They don't have any thickness to them. They are infinitely small. And well, okay, well, you're saying, well, I see the lines. How can they be infinitely small? Well, I can change the size of these lines all I want. Does that mean that these rivers are actually that big or actually that big? Oh, it's going to break everything. Ooh, no. All right, everything is water. The whole watershed is just, no, that's not how this actually works. These are cartographic displays. So when we are looking at things like this, we're looking at them visually, we're looking at them cartographically. They don't actually represent the area of the river or stream or lake in question. If we were to zoom in here to the base map, we could see that, you know, they're in some cases aligned differently. They're in some cases in the center, in the left, in the right, whatever it may be. So what we can do is run a tool called buffer to give these lines a little bit of range to show the area around a line. And that could be for a stream, a road, a railroad, any line data that you might have. Just like any other tool, we can search for it in the geoprocessing tab. We can search for it up in the command search. One thing when we're working with buffer, though, is that we want to make sure we're using the buffer analysis tool. There's something called graphic buffer. Graphic buffer is for cartographic work. We want analytic work. We're just going with classic buffer. Buffer original. Now, buffer has a little bit more inputs that it asks for than clip did. And in this case, I just want to buffer these streams by 100 meters. That's all I'm going to ask. So my input then is, well, it's the streams. If I didn't know that, I could click on this wonderful question mark or even just hover over it. If I hover over it, I'll get this wonderful graphic. If I click it, I'll get the full help document. We love a good healthy help document. I'm going to input my streams. That's what I'm buffering. It gives me an automatic name, Blackstone Streams Buffer, in my default geodatabase. I love a default geodatabase. Actually, Blackstone Streams Buffer works for me. I like that name. I'm going to make sure I know that it's a 100-meter buffer, though. So I'm going to put that in here. Distance 100 unit meters. Is there anything stopping me from choosing, you know, and writing in here 75 inches? Absolutely not. Arc's only going to do what you tell it to. So I'm going to tell it to do the thing that I intend. 100 meters, 100 meters, 100 meters. Everything's lining up just fine. The side type, the end type, and the method we can leave as defaults. These generally operate the way we want them to as their defaults, but you can see a little bit more about these types here. Dissolve is something that we're interested in. There are two types of dissolve. No dissolve. Well, three types of dissolve. No dissolve. Is no dissolve a type of dissolve? Discuss in the comments. So you can either not dissolve, you can dissolve everything into one, or you can dissolve into some unique value. We're going to talk about those top two. What this is essentially saying is, how do we want the geometry? I guess, what is this? This is asking, how do we want the geometry of our new file? We're making a new file here. This new geoprocessing is going to give us this new file. It doesn't exist yet. And again, this tool's not going to edit our old file. It's going to be the same as it is when we're done running this. When we look at the attribute table of our file here, we can see that every river every little line here has its own entry, and there's about 9,500 of them. So I might need all of this information about each of these entries in my little database here, in my shapefile. I might want to keep this for their object ID or for their resolution or something like that. Or I might not care and just want one big 100-meter buffer file out of the end of this. Notice how I cleared the selection. Remember, your analytical processes only run on things that are selected. So I'm just going to go with a full dissolve here. I'm going to dissolve everything into a single feature, which means I'm going to get one big happy feature out of this. There it is. I'm going to hit run on that. While that's running, we're going to think about the attribute table that we're going to see. We're going to see an attribute table that has only one entry, only one feature. And if you look, hey, look at that. Our original lines are still there. They're still happy. And I have this buffered 100-meter shape outside of it. Because I chose dissolve all, I have one shape. So that selection, one shape, this is all one interconnected object. Object ID of one. Okay, you're asking. You really want to know what it looks like if you choose no dissolve. So of course we're going to do that. One of the great things about Arc Pro is that when you go back to the geoprocessing tab, it saves what you've done previously. So if you want to fiddle with settings like this, really easy to do so. So I'm actually going to use that same name, just call it no dissolve. And I'm going to choose my dissolve type to be no dissolve. We're going to run that. In this case, we should expect a shape file that, well, actually looks kind of similar when we look at it, but when we zoom in, we can see that we have lots of overlapping circles. That's because in this file, if you look at this attribute table, all of the files, all of those little river and creek and stream pieces are still there. They're just now represented as their 100-meter bubble. Let's zoom to one just to see what it looks like. There it is. Notice that when you're in an attribute table, you can right click and zoom to anything. Pretty neat. So these are now all represented by individual 100-meter buffers, whereas previously it was just one big happy 100-meter buffer. Certainly there are reasons to do both. You might need that information about all of the individual things in your attribute table. But if I were calculating area, I would definitely be very suspicious about calculating all this overlapping area. There's a lot of overlaps in here, and I might calculate my area really wrong. But the right answer is the answer that is correct for your use. So go forth and use buffer appropriately.